Is this working? Yes, it's working. Okay, I'd like to ask all of you to raise your hands. Raise your hands. I can't see you very well. I was going to ask you a question. Whoever has never heard about climate change, global warming, you can put your hands down. That's good. All those of you who do not believe that climate change is man-made, you can put your hands down. All those of you who've heard about wind, solar, and biomass as sources of renewable energy, you can put your hands down. Have not, sorry. Okay. All those of you who believe that biomass contributes between 1 and 20% of all the renewable energy that we generate today, you can put your hands down. If you believe between 1 and 20% comes from biomass, you can put your hands down. From 20 to 50%, you can put your hands down. And more than 60%, then you can put your hands down. Okay. Well, the answer is more than 60% today. So when we talk about renewable energy, actually, the biggest source of renewable energy, one of the most sustainable ways to create electricity and heat today is biomass. But I just need to go one little step before, one step back. Most of you know that climate change is a reality. It's a fact. The average temperature of our planet has risen by 1 degree since the end of the 19th century, which doesn't seem like much, but 2/3 of that happened since the 1980s. So it's happening recently and very quickly. And there's a consensus of scientists, including the NASA, who believe that climate change is man-made and that it's accelerating. That means that, according to some scenarios, our average temperature on our planet might rise between 2 and 6 degrees Celsius between now and 2050. That means that by the time that you guys are my age or a bit older, the temperature on our planet will be substantially higher. And this is catastrophic. Why is it catastrophic? Because we believe that climate change is the reason behind more frequent and more violent storms and hurricanes and typhoons, the latest one being the Philippines. It contributes to an expansion of the deserts on the planet. It causes the ice cap to melt and sea levels to rise and polar bears to drown. So our polar bears and our ecosystem are not able to adjust and to adapt to the changes in temperature in our planet fast enough. It takes millions of years, hundreds of millions of years for the ecosystem to adapt to such a change. So what are we doing about it, we as humans? Well, there's been some initiatives like the Kyoto Protocol to make industries pay for the right to pollute. There's been carbon taxes introduced in Australia and then removed. They changed their mind. There's politics involved, and sometimes we try and we come up with some solutions, but they're not, as of yet, they're not very, very efficient. One thing is for sure, we try to put the emphasis and to try to generate more electricity and heat for industry and for ourselves from renewable sources. The main 3 sources of renewable energy that we have today are solar, wind, and biomass. Now, they all have advantages and disadvantages. The big disadvantage of solar and wind energy is that it's intermittent. We don't always have sun, and we don't always have wind. So what happens when we don't have wind or sun? We don't produce electricity, and we can store it. We cannot store it. Biomass, on the other hand, can be used as a fuel to generate heat and power continuously, non-intermittently. And this is great. Now, in terms of what are the disadvantages of biomass, biomass is a lousy fuel. It's a terrible fuel. Biomass, I define it as being anything that is woody fiber, anything that comes from nature, plants, bark, trees, clippings from forest, and also residues from the agriculture. That is biomass. It's cellulose. The problem with biomass is that, first of all, it's wet. Typically, when it comes from the nature, it's 50% water. So when you want to use biomass, you need to pre-dry it, or if you don't dry it, then it makes a lot of steam, and it's a lousy fuel. When you try to combust it, it just doesn't burn. You need to pre-treat it before. On the other hand, with solar and wind, the fuel is for free. But I'm going to focus on biomass. What my company did is to develop a technology that was able to turn biomass into an adequate substitute to a fossil fuel. Why do we want to substitute the fossil fuels in electricity generation? Well, because fossil fuels, they contain CO2, which when you, well, let's just say when you burn coal, when you burn oil, and when you burn gas, you release CO2 into the atmosphere. CO2 is a green gas. CO2 is carbon dioxide. And green gases contribute to the warming up of our atmosphere. So we want to substitute those fossil fuels with something which is renewable. So what we do is that we take the biomass and we transform it into a substitute for coal. So what my company did, developed a way to very efficiently turn the biomass into bio-coal, a green coal, a good substitute for the fossil stuff. So what happens to the CO2 actually? Well, when you burn fossil coal, you take effectively CO2 which is stored under the surface of the Earth, and you bring that CO2 into the atmosphere. Whereas the CO2 which is in the biomass is the CO2 which was in trees and plants and so on. Now when a plant grows, it absorbs CO2 from the atmosphere, and when the plant dies, it releases that CO2 again into the atmosphere. This is part of a natural cycle of life, using the CO2 which is, let's just say, above ground. When we use biomass to make electricity or heat, it means that we do shorten that cycle by a few years. So let's just say a tree takes 50 years to grow and to decompose again, and that CO2 that was in the atmosphere goes into the tree and then back into the atmosphere in 50 years. We do that in 5 years. We grow a tree, and after 5 years we chop it, and we burn it. The CO2 goes back into the atmosphere, and another tree grows back. Now, 45 years, which is the difference in time, is a heartbeat. It's a blink in the history of Earth, and it doesn't affect the cycle of CO2 being present already above ground. So this is why we say that burning biomass is CO2 neutral, and this is why burning biomass is a renewable way, sustainable way to create electricity. So how did we do that? How did we effectively do in 200 seconds what nature needs 200 million years to do? Well, we invented a process with a reactor. We take in the biomass, which is wet, full of water, and we put it in the reactor, and the biomass gets heated without oxygen. If you have oxygen, the biomass will eventually burn. So when you heat up the biomass, it turns into some kind of charcoal very quickly. And there's 3 processes that take place in that reactor. The first one is that the water gets out. We go from 50% moisture down to almost 0%. So the water escapes. The second thing that happens is that we densify the energy of that biomass so that there's almost the same energy in a smaller volume. This is what coal has, and that's the advantage of coal, and we want to replicate that. So this densification takes place in 2 ways. The first thing is that we take out the so-called volatiles. Volatiles are things that are in the biomass which don't have much energy, and we want to get it out because it's corrosive and it's not what coal would do if coal was combusted. So we need to get the volatiles out. And in those volatiles, we've got the acetic acid, the one that your teacher mentioned in his previous presentation. Very corrosive gas, actually. The last process that takes place in our reactor is that those long chains of sugars, cellulose, get broken down into smaller blocks of sugars. And this process is called depolymerization. I'll say that again, depolymerization. And we break down the long sugar chains into smaller sugars, and that changes completely the nature of the material. of the biomass. It blackens, it becomes brittle, and basically turns into coal. So what we achieve in these 200 seconds is that we just created biocoal. Then we compress it into either briquettes or pellets. Pellets are actually like little cylinders, cigarette butt sized. And we sell this to the power stations, the coal power stations, to co-fire alongside fossil coal. That means that those power stations are able to accept this biocoal, they mix it with the fossil stuff, and then they can say, look, we used to produce with 100% coal, and now we're introducing 10% biocoal, and then we hope to raise this to 20% of biocoal. So that means that you're substituting the fossil stuff by a renewable fuel. Now this technology is not so complex. It's just a matter of heating up the biomass, but we need to do this efficiently, and we need to do this without loss of energy, which would render the whole process pretty much too expensive to operate at industrial level. We also need to do this continuously, so the biomass goes in on one side and it goes out as biocoal on the other side, whereas in the past we used to put biomass into a big oven, wait for it for 3 hours, and then we would come out as charcoal. This is what we do with our barbecues, by the way. We take a tree, we put it in a big oven, and then we break down the big log, which is all charred, into barbecue coal. So in order to do this very efficiently, we needed this reactor. We needed a lot of money from investors. And the one thing that we're still missing is awareness from the utilities that when we're talking about biofuels, we should also be thinking about solid biofuels. That coal is one of the biggest polluters today in our industries, and that if we were to substitute that coal with a biocoal, then we would get a long way towards reducing the emissions of CO2 into the atmosphere, which in turn contribute to global warming. So the biggest challenge that we have today as a company that has invented this technology is to get some momentum in the awareness, first of people, and then politicians and leaders and policymakers, that they need to encourage the use of treated biomass, we call it, into existing assets, so that we can basically contribute more biocoal to the generation of electricity and heat in Europe and other countries. So, what are your questions so far? Yep. That's a good question, actually. Well, the first thing that I should say is that we're not using rainforests to create the biocoal. Typically what happens is that there's managed forests. Those forests, they grow by 7% per year. And the trees that are chopped are immediately replanted. And by the time you come back to the area of the forest that you've chopped, 20 years have gone by, and you still can have the same ecosystem. And it's a process which is very carefully managed by a club of forest managers. This is not native woods that we're talking about, and that wood used to go into the paper and pulp industry in the past. So there's a whole infrastructure. There's many forests that are meant to go to the paper and pulp, except that the paper and pulp industry is in the doldrums. Nobody uses paper anymore. The demand for paper has gone down. So all these forest managers, they have all this wood, all this fiber, and they don't know what to do with it. It's a bit of a problem for them. So it's probably even the opposite, that we have too much wood and we don't know what to do with it. And they still need to maintain those forests. They grow by 7% of a year, so they need to, there's plenty of forest clippings, and they have all that technical wood they don't know what to do with. That's one thing. But you're right when you say that we also release CO2, fossil CO2, when we extract and transport and even process that biomass into biocoal. For instance, if the forest is in Canada, you need the diesel or whatever fuel you use to chop the trees. Then you transport it, you put it in a big Panamax boat, and that boat is using diesel again to ship whatever product you have across the ocean. True. And the metal that we've even used in our reactor has used fossil coal for, well, the reactions that create steel. Yes. So we're talking about the CO2 footprint. So what is the CO2 footprint of 1 ton of biocoal compared to 1 ton of fossil coal? Well, we've done these calculations and we figured out that if we take everything into account, including the wear and tear of the tires of the truck that is going to bring the biofuel from our plant to a coal station, our footprint is above 78%, meaning it's not 100%. Yes, we do need to release fossil CO2 into the atmosphere in order to create and make available that 1 ton of biocoal. It will never be 100%. But what we try to do is to make it as high a percentage as possible. We try to have a CO2 footprint which is acceptable. This is one of the things that has a bit torpedoed the hopes of liquid biofuels. Because liquid biofuels, we figured out that in order to produce 100 units of energy, of green energy from maize or as bioethanol, then we needed to put into that process something like 90 units of energy just to produce that 100. So your gain is very small. Your CO2 footprint was lousy. And it required a lot of subsidies on top of that to make that 100 units of bioethanol to come into existence. So these are also the challenges that we've been facing with a solid biofuel. We call it a second generation biofuel. It's solid as opposed to liquid. Most of the focus was going to liquid biofuels because we all want to put green petrol into our cars. But actually the solution was much more simple. We need to put a solid biofuel into the coal plants. And the beauty of this is that the coal plant doesn't need to have a special bunker, doesn't need to have a special mill. It just can take the biocoal in, mix it with the fossil coal, and it goes along into the oven to generate electricity. So my time's up. I hope this has been useful. All that remains for us is to convince as many people as possible that this is a viable way to use more biomass as a renewable energy so we can slow down at least the change in our climate. Thank you very much.